So far, we learned about separable differential equation. We know that if we can separate x terms and y terms, then we can just say basically take the integral of both sides and write the solution of the differential equation. For example, suppose we want to solve the following differential equation. dy dx is equal to sine of 5x. First of all, this is a separable differential equation. dy can be written as dx multiplied by sine 5x. Now, it's a separable differential equation. We can take the integral of both sides. The integral of dy is equal to the integral of sine 5x dx. The integral on the left-hand side is easy to calculate. It is just y. On the right-hand side, you get negative 1 over 5 cosine 5x plus c. You can recall that from calculus when you have the integral of sine x dx. This is negative cosine x plus c. The integral of sine ax dx is negative 1 over a cosine ax plus c. So that's how you ended up with negative 1 over 5 cosine of 5x. So basically, we found the family of solution of differential equation up there. So this is family of solution of the differential equation up there. Let us take a look at another question. In this question, we have x dy dx equals to 4y. Is this a separable differential equation? We can easily apply algebra and manipulate this a little bit. We can see that it can be written as 1 over y times dy equals to, you have 4 over x dx. Indeed, it's a separable differential equation. Since it's a separable differential equation, we can take the integral of both sides. The integral of 1 over y dy is equal to the integral of 4 over x dx. Well, the integral on the left-hand side is nothing but ln of absolute value of y, and on the right-hand side you have 4 times ln of absolute value of x, and you have the constant of integration as well. So from calculus, remember that if you have the integral of du divided by u, it is always ln of absolute value of u plus c. If u is positive, then you can get rid of the absolute value. Absolute value of u is equal to u. But in general, if you don't have this piece of information, you have to leave it as absolute value. Now let us go back to the definition of absolute value. ln of absolute value of y is 4 times ln of absolute value of x plus c. What's the meaning of that? It means that absolute value of y can be written as e to power 4 times ln of absolute value of x plus c, or absolute value of y is equal to e to power 4 times ln of absolute value of x times e to power c. Okay, what we can do as well, we can get rid of absolute value and write y as plus minus e to power 4 ln of absolute value of x times e to power c. But note that this guy can be called c1, which is just the new constant. We can just relabel this plus minus e to power c as c1. And at the same time, e to power 4 ln of absolute value of x can be simplified as, so e to power 4 ln of absolute value of x can be written as e to power ln of x to the 4th, and you can get rid of e and ln, you have x to power 4. So the solution of this differential equation can be written as y equals to c1 times x to power 4. We found a family of solution of the differential equation which are multiples of x to the 4th. So these are the family of solution of the differential equation. You can plug in different values for C1 and graph these as a family of curves in XY plane.